Well, I'm going to go ahead and go over 5.2, dividing polynomials. When we first start dividing polynomials, the basic form of dividing a polynomial is actually dividing a polynomial by a binomial. So when we say polynomial by a binomial, a polynomial has multiple monomials in it. So in this case, this top one here, it has 3 monomials. And it's called a polynomial because it's made up of 3 monomials. On the bottom here, we have a monomial. I know that's a monomial because it has no negative exponents. It also has no plus sign, minus sign, division, or anything other than just multiplication. So when we're doing specifically a polynomial divided by a monomial, we're going to be breaking the problem up. So I'm going to break this problem up. And I'm going to break them up into baby problems. So we're going to take each of the terms in my polynomial and divide it by our monomial. So I'm breaking it all up into smaller parts. So all I'm doing is taking the top and dividing each of the top terms by the bottom term. Okay, so no math just yet, just breaking it up. Now that I did that, I'm going to go ahead and start simplifying each of my terms. Okay, so 5 divided by 5, those are going to simplify, those are going to cancel out. When we are simplifying exponents and we're dividing, so in this case I have a 2 here, and there's an imaginary 1 right there. What I'm saying is 2 minus 1. So what I'm left with is just an A. Now I have a B on the top and a B on the bottom. So really what we're saying is 1 minus 1, which is 0, so those are going to cancel. So we're done simplifying our first term. Then I have a minus sign, and then I'm saying 15 divided by 5, which is 3. I have an A on the top, specifically A to the first power, and A to the first power on the bottom. So those are going to cancel. Then I have a 3 and a 1, so I'm left with B squared. Plus 10 divided by 5 is 2. Then I have a 3 and a imaginary 1, so we're essentially saying 3 minus 1, so I'm left with A to the second power. Then we're saying 4 minus 1, so I'm left with B to the third. And that is our final answer for our first example. So we're going to do the same exact thing for B. Again, we're dividing a polynomial by a monomial. So I'm going to rewrite my terms. And then under each of them, I'm going to put the monomial we're dividing by. So we're going to get started again, and I'm going to go ahead and I'm going to say, okay, 4 divided by 1, well, that's just going to be 4. Then I have an x on the top and an x at the bottom, so those will cancel. And I'm saying 2 minus my exponent of 1. So 2 minus 1 is just going to leave me with y to the first power. Minus, well, 2 divided by 1, because there's an imaginary 1 under this, is just 2. X is going to cancel, y is going to cancel, so we're just left with 2. Plus 2, 3 minus 1 is going to give me x to the second power, and my y's will cancel. So that's my final answer. I want to do one more of dividing monomials. So again, here we go. We have a polynomial divided by a monomial. So I'm going to rewrite this problem. I have 12x to the second power over 4x minus 4x over 4x minus 8 over 4x. Okay, so I'm going to start with my numbers. So 12 divided by 4 Here, what we're really doing is dividing the top and the bottom by 4. So the 4 divided by 4 is going to cancel. 12 divided by 4 is 3. 2 minus 1, we're just left with an x. Minus, and careful here, 4x divided by 4 is going to cancel. But when we cancel, it's actually a 1. It's not a 0, which is different. So these are going to cancel each other out, leaving us with just a plain old 1. Then we have minus, and then 8 over 4. So I'm saying 8 divided by 4 is 2, but I still have the x. I can't just bring that x up. He's going to have to stay on the bottom. Okay? To know where your variable stays when you do the subtraction, you look at where the greater number is. So in this case, my greater number was 2 versus a 1. So then that's why the x is on top. But if it was reversed and the 2 is on the bottom, then we would have an x on the bottom. So wherever the greater amount of exponents is, that's where your variable is going to stay. The next thing we learned in chapter 5.2, it was dividing again, but instead of dividing by a monomial, what we're dividing by is a polynomial divided by a polynomial. I know this is different than a monomial because notice how I have x minus 5. So now we have a minus sign here. So I'm going to go ahead and set up our long division. So this is going to look just like it did when you were probably in elementary school, where we have the long division symbol. This process is not too difficult. The math behind it really is just adding and multiplying, adding, subtracting, and multiplying. So we start this by asking ourselves the question, x times what? And we're asking this x times what is going to give me x squared. So x times x, that's going to give me x squared. Then I'm saying negative 2 times the x is going to give me negative 2x. Okay, so let me repeat that. I started by looking at this guy and I asked myself, x times what is going to give me x squared? So what I found was that x times x gives me x squared. And that's what I put underneath it. We can't forget the negative 2. So then I multiplied negative 2 times x, and that's how I got my negative 2 on the bottom. All of that we are subtracting. And this is the place students make the most mistakes. So we're going to say x squared minus x squared. So that's going to cancel x squared minus x squared because we're distributing this negative. And if I distribute the negative, now really what I'm saying is negative 2x plus 2x. So that is going to cancel. Negative 2x plus 2x is going to cancel. So we're left with 0 so far. And I'm going to bring down my negative 15. So then I ask myself, x times what is going to give me negative 15? Well, there's enough times x that's going to give me just a negative 15. If this was a negative 15x, then yeah, we could go ahead and do it. But since it's just negative 15, I can't do anything. So that's actually our remainder. I'm going to go ahead and write it as our remainder. Whenever we have a remainder, all we do is take the number and put it over what we divided by. So x plus 2. Or that was actually we divided by. I made a mistake. I wrote this problem wrong. Let me erase this and start over. There we go. Okay, let me write this over. So we're starting with our long division, and I wrote 2. Here's my long division symbol. So again, we're starting with the same exact question. We are asking ourselves, x times what gives me x squared? Well, x times x gives me x squared. So that's what's going to go on the bottom, x squared. Negative 5 times x is going to give me negative 5x. All of that we are going to subtract. Okay, so I'm going to distribute the negative. So really what I'm saying is x squared minus x squared. That's going to cancel. And then I'm saying negative times a negative is going to give me a positive 5x. So I'm saying negative 2x plus 5x. Well, that's going to leave me with 3x. And I bring down my negative 15. And we start the process over. We ask ourselves, x times what is going to give me 3x? And I want a positive 3x. So I'm saying plus 3. So x times 3 gives me 3x. Then I'm saying negative 5 times 3, well, that gives me negative 15. And all of that we are subtracting. So I'm saying 3x minus 3x, so that's going to cancel. And I'm saying a negative times a negative, so I'm getting negative 15 plus 15, so I'm left with 0. So we have no remainder. X plus 3 is my final answer. Let's do another one. So we set it up the same way, so it's a plus 1. Here's my long division. So we're saying 2a squared minus 4a minus 8, and I'm asking myself, a times what is going to give me 2a squared? Well, a times 2a is going to give me 2a squared. And I can't forget about the 1, so I'm saying 1 times 2a, or 1 times 2a is positive 2a. All of that we are subtracting. So what I'm saying is 2a squared minus 2a squared. Then I'm saying negative 4a, and this negative also applies to this positive here. So negative 4a minus 2a gives me a negative 6a, and we bring down our negative 8. So again, we start the process over and we ask ourselves, a times what is going to give me negative 6a? Well, negative 6. So a times negative 6 gives me negative 6a. 1 times negative 6 is going to give me negative 6. Okay? And don't forget, we're subtracting all of this. So then I'm saying negative 6a, and we're saying plus 6a. So that's going to cancel. And then I'm saying negative has a negative, so I'm saying negative 8 plus 6. That's going to leave me with a negative 2. So we're left with a remainder. So remainder, all we have to do is go ahead and say minus, because it's a negative 2. And we just write it over what we divided by. And that's all we do when we have a remainder. Okay, so that was long division. I'm going to do one more with long division. So this is a different way to write it, but it's asking us the same exact question. So we're going to set it up exactly the same way. So I'm going to say x plus 2. Now, when we're doing long division, we have to make sure we take the time to check our exponents, because our exponents have to be in descending order. So when I'm dividing, I should go 4, 3. Now here's the problem. I'm jumping from 3 to 1. I need to have an x squared term. So when I write my problem, I'm going to go ahead and write it, but I'm going to put a 0 for x squared. So here's my x to the 4th minus 3x to the 3rd plus 0x to the 2nd power, because it has to be in descending order, and then I can keep going. So plus 5x minus 6. Okay. We're going to start the process just like we did with our last one. So x times what gives me x to the 4th? Well, x to the 3rd does. So x times x to the 3rd gives me x to the 4th. Then I have x to the 4th. 2 times x to the 3rd is going to give me a positive 2x to the 3rd. Those two we subtract. So x to the 4th minus x to the 4th, that's going to cancel. Negative 3x minus 2x to the 3rd is going to give me negative 5x to the 3rd. And we bring down our next term. So we're bringing down our plus 0x to the 2nd power. So we start over. Then we ask ourselves, okay, x times what is going to give me negative x cubed? Well, x times negative 5x squared gives me what I need. So x times negative 5x squared, that's going to give me negative 5x to the 3rd. And 2 times negative 5x squared, that's going to give me negative 10x squared. All of that we are subtracting, and we're going straight down. So I'm saying negative 5x to the 3rd. We're distributing the negatives of negative 5x to the 3rd plus 5x to the 3rd. That's going to cancel. 0x squared. Don't forget, since it's a negative out here, this is actually becoming a positive x, 10x squared. So 0 plus 10x squared is going to leave me with 10x squared. And we bring down our 5x. So plus 5x. We ask ourselves the same question now. X times what is going to give me 10x squared? Well, plus a 10x. So x times 10x is going to give me 10x squared. And 2 times 10x is going to give me a positive 20x. All of that we subtract. So 10x minus 10x, that's going to cancel. Negative times a positive, I'm saying 5x minus 20x, that's going to leave me with negative 15x. And I bring down my last term, which is negative 6. So we set the process over. I ask myself, x times what gives me negative 15x? Well, x times negative 15. So x times negative 15 gives me negative 15x. 2 times negative 15 gives me negative 30. All of that we are subtracting. So I'm saying 15x plus 15x, those are going to cancel. Negative 6 plus 30, that's going to give me 24. And it's going to be a positive 24. Okay, so that's my remainder. So I'm left with a positive 24, and since it's at my remainder, I'm just going to write it over everything I divided by. And that's our final answer. So that was long division. We also learned a different method called synthetic division. With synthetic and long division, you can use them interchangeably. So if you like this method better, you can always use this method. So to set up synthetic division, we take the opposite of what we're dividing by. So in this case, it's negative 2. So when I place it in my box, it's going to be a positive 2. Then I look to make sure, just like I did with the long division, that my exponents are in descending order. So I'm going from 3, 2, 1, there's nothing there, and nothing. So there's no. So it's going 3, 2, 1, 0. Now, if we were missing a term like we were with our long division, all we would do is add a 0. So I'm going to take the coefficients of each of these terms. Since this guy doesn't have a number, its coefficient is 1, so I'm going to put a 1 there. Then I'm going negative 4, 6, and negative 4. So we've just set it up. These numbers are the numbers that come from our coefficients. To start this process, I drop down our first number. Then I'm saying 2 times 1 is 2. So that's what goes there. Then I go down. Negative 4 plus 2 gives me negative 2. And I multiply again. 2 times negative 2 gives me a negative 4. Now I go down. So 6 minus 4 leaves me with a 2. 2 times 2 is 4. Negative 4 plus 4 is 0. So we're done with this problem. All I have to do now is simply rewrite it. So when we rewrite synthetic division, we always write our answer with 1 less degree than what we started with. So in our problem, it was x to the third. So when I write my answer, it's going to be x squared, or you can say 1x squared, minus 2x plus 2. And now I don't add the 0 because that would be adding nothing. If this was a number in the back, then we would have a remainder. But since it's 0, what that's telling me is that I have no remainder. So this is our final answer. Let's do another synthetic division, and that's going to be it for today. So another type of synthetic division is when we have a number in front. We're not allowed to have a number in front. So what we do to start this problem is I'm just going to divide each of them by the coefficient. So now what I'm dividing by is y minus 1/2. Okay, so I'm going to set up my synthetic division. And now what's going in my box, remember, it's opposite of this number. So if it's a negative 1/2, I'm going to put a positive 1/2 in my box. And we simply take the coefficients of our guy we're dividing by. Now, look at your exponents, make sure it's in descending order. So 3, 2, 1, and there's no variable. So I can just go ahead and rewrite it. Don't have to worry about adding any zeros. Minus 6, then we have a 4 minus 1. And we'll start by dropping down our first number. So now I'm saying 4 times 1/2. So really what that 1/2 is doing when we're multiplying, it's just taking half of 4. So 4 times 1/2 is going to give me 2. Negative 6 plus 2, I'm going down now. Negative 6 plus 2 is going to give me negative 4. And again, I go here. Negative 4 times 1/2 is negative 2. 4 minus 2 is 2. 2 times 1/2 is going to give me a 1. Negative 1 plus 1 is going to give me 0. Now, if you're wondering, how do I know if I'm adding or subtracting? Well, you just look at the number. So if your number is positive, we're adding. If it's negative, we're subtracting. If it's positive, we're adding. That's how you know if you need to add or subtract. So because we have a 0, again, we have no remainder. My highest degree was 3, so when I rewrite my answer, my highest degree is going to be to the second power. So it's going to be 4y to the second power minus 4y plus 2. And that would be our final answer. So we just covered dividing by a monomial using long division and synthetic division. That's everything we did in 5.2. If you need further guidance, make sure to check out your textbook. Have a wonderful day.